welcome back to my bench. If this is your first time here, my name's Dave, and I repair electronics, mostly stuff from radio stations. But today, we got this. I bought this thing a couple of years ago, I think now, and I've never been able to get it to work. I just figured it was a piece of junk, and decided, you know what, I'm going to figure out what's wrong with this thing. I've checked the caps, I've checked everything. Values seem to be fine. I did, however, recently find a schematic for this looks like almost identical unit. Here it is. It doesn't have the volume control on it, but I don't care about that. But it looks like pretty much everything is the same. This is a TDA2030A. Supposed to be a 15-watt amplifier, but it ain't going to be 15 watts for very long with that little tiny heat sink. It's designed, I mean, it's a nice little design. I have a use for something like this. And I want to see if I can get this working. I spent $2 on this, darn it. And I want it to work. So anyway, so what we're going to do is I'm going to show you what I got out of this thing. Let's see, that is negative, that's ground, that's positive. Let's get rid of the manual here for a minute. Okay, that's my voltage. Go away, thank you. All right, that's input. That's input. All right, let's get the scope up here. There's my scope. Let's put a little voltage into this thing, and I'll show you what it does. It's kind of weird. I mean, it doesn't do hardly anything. There's a light. I got about, it does that. It slowly raises in voltage, DC, and doesn't do anything. I got 100 millivolts of 700 hertz going into it right now, and that's all it does. And if I turn the volume control here, it just is like garbage. I don't know what that is anyway. And it's drawing about 230 milliamps at 9 volts, which is this supposed to run at 9 volts, 9 to 12, I think. Anyhow, so we're going to do some measurements. Get rid of that. Put on the meter. All right, there's my meter. I'm in ohms. Okay. So let's get the manual back up. All right, so what do we got here? Well, let's start. Where is it? This is R1, 2, 3, and 4. So let's start. R1 should be 100K. What do we got? 90, 102, 103, so that's okay. That's good. R2 should be 100K also. And we got 80. Okay, I can take that as long as it's not higher. R3 is what? 100K. And 50 and going up. Okay, that's fine. All right, and let's see. R4 is 100K. Where's R4? R4. Right there. 4.6? 4.7K. Oh, maybe is it across something else? No, it's not. I mean, it's, if we look up here, it's right here. It's not across to any R4. Okay. Well, let's take a look at, what is it? R5 is right here. And it is 100K. It's supposed to be for, wait a minute. Let's look at this thing closer here. Okay. I don't even know if I can show this to you. I don't think it'll focus in that well. Well, if I pull this out, I think, maybe. Can we see that? Come on, focus, focus, focus. Look at R4. It says 472. R5 says 104. Those resistors are reversed. Everything else on this little board matches that schematic down there. I never saw that. All right, well, can it be that simple? I don't think it can be that simple. Really? Just, it was made wrong? It was made wrong? I don't know. Let's find out. Got my little tweezers here. Let's see. Sorry about the glare. Let go. Jeez. Okay, there's one. There's the other one. So, let's put a little goo on here. And a little solder wick. Cut it off. You don't generally think of this stuff just being somebody made a mistake, because usually, to my knowledge anyway, people don't actually build these anymore. These are all done by pick and place machines. All right. And I wonder how many of these got done this way if the pick and place machine was wrong, was loaded incorrectly, or come on, turn over. Which one are you? All right, so that one is, yeah. That's the 470, 4.7K. So the 4.7K is R5, which is the second one down. Okay. Whew. Can I do this so that you can see what or try to see what I'm doing here? This is really small stuff to be working. There's one side. There's the other side. Alright, and then this one's the 10K, or 100K. Well, that's a big difference. Got to hold your tongue at exactly the right angle here. Wow, I'm trying to get around that pot. It's not all that easy. Let's get rid of the manual for a minute. Okay. Ack. Oh, get off of there. Really? Okay. These tweezers are not the best things to try to solder back onto the board with. Because the little parts have a tendency to sort of stick to the tweezers a little bit and they pull away when you do it. They're great for taking stuff off. I love them, but there we go. All right. Not perfect, but good enough. All right. Well, I wonder if it blew it up being backwards like that. Because, you know, I wouldn't have found that without a schematic. I mean, I don't know what's supposed to go where. All right, so this is my input. Bring you back out a little bit. Okay, so this is my input. Right there. This is my output over here. And this is my voltage right here. Now, it says it's doing 20 milliamps, but where is the scope? Whoa. Where'd the scope go? Okay. Well, that's completely different. Okay. Turn off channel 2. Aha! We have what appears to be a sine wave, but it's DC coming out of there. What? What? Okay. I made that probe specifically for this. I mean, it's not perfect, but it's close. It'll do. Right there and right there. And right there. All right. Basically, it's just a capacitor. 2 volts, 500 millivolts, 100 millivolts. Aha! We have a sine wave. Do we have volume control? Yes, we do. All right, so that's going to be times 10. Basically, it's times 10, so that, yeah. Okay. What do we got here? Amplitude's 216 millivolts. So our RMS, 7.5 millivolts. All right, well, I can't. Tell you what, I'm just going to measure this on the scope that I can see because I can't keep losing it. And I'll just tell you all what I get. Okay, well. Whoa! Alright, so I'm on half a volt here. And I've got 0.51, 0.52. So I got 2 volts coming out of here for 0.1 N at 9.5 volts. All right, well, let's take this up a little bit. Let's take it up to half a volt. Oh, yeah. Oh, yeah. Well, that flat tops it. There. So I got half a volt in. I've got 2 volts. Well, wait a minute. 2, 4, 6 volts out at 9.5 volts of DC. Well, this thing says that it should be able to run at 12. There's 12 volts. I crank it. Oh, yeah. So at 12 volts, I could get 2, 4, 6, 8 and a half. So I got 8.5 volts of pretty good looking sine wave. Maybe I can. Let's see if I can do this. This is going to screw up everybody on Earth here. I'll just hold it there. There we go. Can I turn this down or up? Boy, it does not like that. Anyway, you can see 2, 4, 6, 8.5 or 9 volts. 9 volts peak to peak out. Cool. So it works. Well, it works. Can I even get you back again? So that's, all right, well, okay. Resistors flopped around, 4.7 and 100K. So now it works. Good, fine, wonderful. All right. I was going to save my $2 I spent on this thing one way or another, folks. Hey, just for fun, I hooked it up to a speaker over here. Let's see. Turning it up slowly. Oh, yeah. Take my input down to 0.1. Yeah, there's 1 millivolt or 100 millivolts in. Driving an 8-ohm speaker. Perfect. It's no longer junk. Hey, thanks for watching. Till next time.